Good evening, friends. So, welcome to another interview preparation session. So, let's take the first question of the day. So, today we'll be covering deep learning. So, let's take the first question. What is Pfidf vectorization? Yeah, Anand, good evening. So, what is TF-IDF? Okay, before taking this question, let's know what is term frequency or TF. Yeah, Naveen, correct. So, first we must know what is term frequency. So, okay, so term frequency is the number of occurrences of a specific term in a document. Okay. Then let's take what is document frequency. Yeah, so what is document frequency? Yeah, so document frequency is the number of documents that contains a specific term. So here we have inverse document frequency. So inverse document frequency is nothing but log of n total number of documents by document frequency. So we can write document inverse document frequency is equal to log of n, means total number of documents, by document frequency. So TF-IDF becomes the multiplication of term frequency and the inverse document frequency. So we can say a term frequency inverse document frequency is a numerical measure that allows us to determine how important a word is in a document. What it does is this inverse document frequency, the words like and, in, on, like that's common terms, it eliminates all those terms. And from this we can get the rare occurring terms quite easily. Okay, so let's go to the next question. What does NLP stand for? What is NLP basically? What is NLP? Yeah, Shine, correct. So NLP basically stands for natural language processing. So it is the study of programming computers to learn large amounts of textual data. So we can say examples of NLP includes tokenization, stop words removal, stemming, sentiment analysis, etc. Okay, so which is more preferable? Which is more preferable for text mining between Python and R? Which language would you prefer for text mining? Yeah, post tagging also is an example of NLP. Yeah, correct. So Python is more preferable because of mainly because of Pandas library, which provides us ease of use with data structure, and it also has high performance data analysis tool. R, we can say R is more suitable for machine learning. Apart from means deep learning, Python is more suitable. And also Python is faster while performing text mining than R. Okay. So what are the fundamentals of neural network? Moving to neural network now. So how does neural network come by? Okay, so neural network aims to imitate a human brain, we can say, and it is means it contains neurons which are combined together to perform a task. So what it does, it generalizes, no, it learns the patterns underlying from the data and uses this knowledge to predict on new data. And main thing is it doesn't require any human intervention. Hence, just we do not give any input or output. It does it on its own by learning, means after learning. So we can say, okay, let's take the next one. What is the simplest form of a neural network? Okay, so I'll tell the answer. So the simplest form of a neural network is called perceptron. So it contains a single neuron which performs two operations. A weighted sum of inputs means inputs then multiplied by its weights, and then an activation function, and it gives an output. So let me draw it. Yeah, basically. So this is input 1, this is input 2. Then we have here weights 1, weights 2. So I1 into W1 plus I2 into W2 is and getting in here. And then we have some activation function here. Activation function. So it does the sum here. Sum, then we have activation function, and we after moving from activation function, we get the output. So this is the simplest form of the neural network. In more complex form, we have something called as, means between these two layers, we have some hidden layers. There can be multiple hidden layers in between them. Okay, so let's take a look. So next is, yeah, So next is structure of neural network. So what is basically the structure of neural network? So we had discussed, it is similar to this one only, but we have some added things also. Okay, so for this we have in okay. So we have some inputs, and there may be hidden layers in the likewise. Then it all goes to here some weighted sum. Then we have something called bias. Bias gets added here. Then we have the activation function. And after this, we get the output. So this is basically structure of an artificial neural network. Okay, so let's go to the next one. How are the weights initialized in a network? So how do we initialize weights in the neural network? Okay, so there are two methods with which we can initialize the weight. First method is we can give zero weights. Zero weightage. We can initialize the weights to zero. So it makes the model linear, and all the neurons and every layer perform the same operation only. And so basically it is a linear model only. So next one, we can say we can initialize the weight randomly. So we don't have any specific method. We initialize either to 0 or we do it randomly. Generally, we do it randomly. So the weights, when we are doing randomly, we are taking the weights very low value, means very close to 0. So it gives us better accuracy of the model whenever, means the neuron performs computations. So we generally use this method. This is generally used. Zero weights is rarely used, but you can say it is outdated. Okay, so yeah, so what is cost function? Yeah, Ankita, HA initialize method. Yeah. So friends, what is cost function when we are talking about neural networks? Okay, so cost function also known as error function or loss function is a measure to evaluate how good, yeah, it is a measure to evaluate how good your model's performance is. It is used to compute the error on the output layer during back propagation. We push that error backwards through the neural network and use that during the different training functions. So we'll be taking back propagation later, talking about that. Yeah, but it is not, yeah, it is actually that only. But in neural network, it, when we do back propagation, then we calculate the error function. Okay, so next, what are hyperparameters? difference. Okay, so when we are talking about neural networks, hyperparameter is uh, used very often. So we can say hyperparameter is a parameter whose value is decided before the learning process begins, and this value influences the output. So it determines how a network is trained and also the structure of the network. The structure of the network, we can say, like number of hidden layers, then the learning rates, then epoch, how many epochs it needed, it needs, all that data we are deciding earlier. So what will happen if the learning rate is set inaccurately? Yeah, okay, correct. Hyperparameter is the value which is given by users to the algorithm's attributes to learn in a better way. Correct. So the next question, if we set the learning rate inaccurately, what will happen? Okay, so it basically has two cases. Yeah, correct, Ankita. So it basically has two cases when we set it to too low or too high. So if the learning rate is set too low, what happens? And if it is set to too high, then what happens? So as Ankita has already written, learning rate is the speed of weight updation. So if it is too low, if the learning rate is set to too low, then the training of the model will progress very slowly, and it will make very minimal updates to the weights, and will get to the critical points very, means it will take a long time to reach the critical points. And if it is set to too high, then we means it causes undesirable behavior of the loss function. Means it may fail to converge only. Means if we have this, if we have a curve like, sorry, we have a curve like this. In case of it is like gradient descent. So if we have to reach here, and if we are setting the learning rate to too high, then it may not reach here. It may jump from here to here only. So we'll never reach the critical points. Okay. So next question. So what is epoch, batch, and iteration in deep learning? Yeah, friend. So what is epoch, batch, and iteration in terms of deep learning? Okay, so epoch represents one iteration over the entire data set. One loop over the entire data set is known as epoch. And batch refers to the uh, thing when we cannot pass whole of the data set into the neural network at once. What we do is we uh, uh, divide them into batches, several batches, and we perform the side operations on them batch wise. So that is batch. And for iterations is the total number of cycles we are covering. So let's take an example, like if we have say 10,000 images as that data. Okay, so say if we have 10,000 images, and we have batch size of let's take 200. So number of iteration it will take is equal to 10,000 by 200, which comes out to be 50. So it will take 50 iterations to train the whole data. Okay, so coming to the next one. What is CNN? Yeah, CNN stands for convolution neural networks. generally perform this operation on image data. So what are the different layers what are the different layers we find in CNN? Apart from, yeah, Naveen, correct. Apart from input output layers, what are the different layers we find in CNN? Okay, so we have basically four layers, namely convolution. We have something called convolution layer. Then we have ReLU layer. Then we have something called pooling layer. And then we have fully connected layer. Okay, so the convolution layer performs convolution operation uh, in which it creates several smaller picture windows to go over the whole data. Then ReLU layer, it means it converts the network into a non-linear table. It converts all the negative pixels to 0. So we get an output which is a rectified feature map. Then we have pooling layer. Pooling will become, okay, pooling is nothing but downsampling of the operation to reduce the dimensionality of the feature map. Then we have fully connected layer. So this is the main layer which recognizes and classifies the objects in the image. Yeah, Ankit, correct. Yeah, Naveen, you are also correct. So next is, what is pooling? What is pooling in CNN? Okay, so pooling is basically used to reduce the dimension of a CNN. So it performs down sampling operations to reduce it, and it creates a pooled feature map by sliding a filter matrix over the input matrix. Yeah, correct. Okay. So basically, it is a means dimensionality reduction thing. Then What is RNN? Yeah, Naveen, correct. Yeah, recurrent neural network, correct. So it is a machine learning algorithm which makes use of artificial neural network. So it is used to find text data. Yeah, we can say it is used for text data, but uh, which kind of text data is also important. So it is used to find patterns in a sequence of data, sequence of data like in time series, stock market, in temperature data, etc. So they are kind of a feed forward network in which information from one layer is passed down to the another layer, and each node here performs some mathematical operations on the data. Okay, so next one, why is it why is RNN called so? Why is RNN called RNN? Means it is called recurrent neural network. So why is it called, yeah, Ankita, why is it called recurrent neural network? Yeah, Naveen, you're correct about RNN. But yeah, why is the RNN called RNN means recurrent neural network? So okay, so RNN is called recurrent because it performs the same operations on some data every time it is passed. Means the algorithm is same, that output may be different, but the means operation is same. And also RNN store contextual information about previous computations in the network. Yeah, basically it is reusing the data, the means patterns which it learned from the data. Okay, so next, what is LSTM? Yeah, Ankita. Yeah, so what is LSTM? Yeah, so LSTM is long short-term memory, and it is a yeah, long short-term memory. So it is a kind of a neural network which is capable of learning long-term dependencies, and it remembers information for long periods. And yeah, so basically that is it. Next one is, what is MLP? Okay, friends, this is the last question. Yeah. So MLP, Ankita, you're correct. Multi-layer perceptron. So what is a multi-layer perceptron? So we already have gone through what is a perceptron, simplest form of neural network. So perceptron consists of uh, a neuron, a single neuron with two operations, that is sum of weighted sum of the inputs, and then we have something called as activation function. So in multi-layer, what happens? We have added hidden layers in between the weighted sum and the activation layer. So when we are considering a single layer perceptron, means a simple perceptron, we can only classify linearly separable classes having binary outputs. But yeah, again, correct. So when we use MLP, we can also classify non-linear cases in this case. So basically, it is used for non-linear cases. Okay, friends. So we'll be closing our session here. Thank you.